Let's continue with some ideas we've seen and revisit something that we haven't touched on in a little bit. Do you remember, it's been some time, but we saw this. Sine squared of t plus cosine squared of t equals 1. So we called this the Pythagorean identity, and it was based on the fact that if we're inside that unit circle, then x represents cosine, sine represents y. So if you're inside a right triangle, then x squared plus y squared equals the hypotenuse squared. And we're in this unit circle where we said the hypotenuse is always 1. So I don't know if you recollect this, but so this is what we established some time back, this Pythagorean identity, because cosine's x and sine is y. Okay, well, we can make some alternate versions of this that it could be useful, and we get some additional identities. And here's all that they've done. Which is which? Yeah, I'll do the first one. So if you divided everything by cosine squared, of course in mathematics, as long as you do something to one and do it to everything, you're allowed to do it. So I've divided this entire equation everywhere by cosine squared. Do you see what would happen? This has now become sine squared over cosine squared. Well, that's tangent. And here, cosine over cosine squared is 1, and this 1 over cosine squared is secant. So we can create this equation here. Now, if we wanted to, we could do the exact same thing. Let's say we didn't do this, and we instead had divided the entire equation through by sine squared. Well, if we had done that, we're going to come up with this equation here. So just a little trickery to give us two alternative versions of that Pythagorean identity. Okay, now we're going to use the Pythagorean identity here, but the truth is, with a little practice, I'll show you the Pythagorean identity approach here, but the truth is, just thinking of this as a triangle would be a lot easier. But here's what we've got. They've told us the value of cosine, and they want us to find all of the other identities from this. Okay, well, so what we've been doing so far is we had both sine and cosine. That would allow us to find everything. So hopefully, we've done that several times. Hopefully, feel comfortable with that. Well, now what they're saying is they've only given us one. They've only given us cosine. Well, what could we do? Well, the Pythagorean identity would allow us to find sine. And if we have cosine and sine, we've got everything we need. So look what we've done here. So we knew cosine. We're using that identity, just doing some complicated, rather unfortunate math, and I'll show you an easier way in just a minute. We do all of this math, get a common denominator here, just a bunch of basic arithmetic stuff. Now we're square rooting. So that means sine is either plus or minus the square root of this right side. If you've got a fraction underneath a root, you can break it into two individual square roots. So all of this to say sine is either plus or minus 5 over 13. Well, we've seen this question before too. Well, which is it? Is it plus or minus? Well, let's go back. We were in the fourth quadrant. So sine in the fourth quadrant is negative. Okay, so we've established that sine of t must be equal to negative 5 over 13. All right, well, we have cosine and we have sine. We can do everything else we need, just like we've been doing in the other videos. I'm just going to use the definitions. I don't know what happened there, but that was negative 5 over 13. So just using all the definitions, I can keep, change, flip, reduce it all, and I create all of these guys. Now, I'm not going to walk through this. We've seen this a lot. If you need some help with this, let me know. But do you see I'm just using the definitions again? We've done that several times. Okay, now let's try another one here. And okay, so I'm trying to think through what they're telling me here. So they're telling me that our angle is somewhere either in the first or second quadrant. Okay, so we've got some investigating to do here. Well, secant, first thing I'm going to do is secant is 1 over cosine, right? That's true. So if secant is negative 17 over 8, then cosine, so let's go back the other way, cosine must be 1 over secant. And so I could just put in 1 over negative 17 over 8. Flip that around, I get negative 8 over 17. Do you agree with that? Just flipped it upside down. So now I know cosine. And here's also what I know. I know, so a little trickery here. I know cosine is in this negative, so this is quadrant 2. I am in the second quadrant. It has to be because cosine has turned out to be a negative value, so I know I'm over here. So I've got some triangle here in the second quadrant. Now I have cosine, so here's what I could do. I could do cosine squared plus sine squared equals 1. So I could do negative 8 over 17 squared plus sine squared equals 1. I could solve this. Now here's the problem. This is totally true, and we could figure this out, and then we're going to get a plus or minus, and it's sine, so sine is y. So we know the value is going to be the positive. I could think that all the way through, but there's an easier way. Look what we've got here. I can just use the triangle. So cosine is also opposite, or no, I'm sorry. Cosine is adjacent over hypotenuse. So I know that the side adjacent to this angle is negative 8. I know the hypotenuse is 17. So I'm just going to use the regular Pythagorean theorem. And the reason I'm choosing to do this is the math is much easier. I don't have to work with the getting the common denominators here with all the stuff with fractions. It's much, much faster. So let me show you what I mean. So wouldn't the Pythagorean identity or theorem just say negative 8 squared plus b squared is going to equal 17 squared? So this is 64 plus b squared. I don't know what 17 squared is. 289. Okay, so I'm just going to subtract 64 from the other side. I get b squared is 225. Square root this. I get b is the square root of 225, which is 15, isn't it? So this would be that b is plus or minus 15. Well, we're talking about y, and since we're in the second quadrant, that's positive. So b must be positive 15. Now, why have I done that? If I know the three sides of this triangle, I can just use the definitions, these alternative definitions, the adjacent over hypotenuse idea, these just the triangle definitions to find everything. You could do it any way you want. But let's just do multiple ways you could finish this. But let's say sine of t then. Sine of t is opposite over hypotenuse. So that's 15 over 17. Now I have cosine, I have sine, I have everything I need to just finish the rest of them. Let me just do tangent here. So tangent is then 15 over 17 over negative 8 over 17. Now you keep change flip. Do you see that what's going to happen is you're going to wind up with 15 over 8. So flipped it, the 17s will cancel. I get this. Now tangent, though, we also know is opposite over adjacent. Opposite was 15, adjacent was negative 8. So what I'm saying here is we could just we could use the Pythagorean identity, and it's helped to find sine, to find the other one of the two key ones that we have to have. And it will work, but it's actually simpler to think of this by just setting up the triangle. The math will be much easier. Once you have sine and cosine, you could solve these any way you want. You could just use the definitions of cosine and sine to find all the others, or we can use the fact that we have the whole triangle set up. Cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. Tangent is opposite over adjacent. You could just do it that way. The rest of these we could just find by flipping cosine, sine, and tangent upside down. Okay, now we're just going to get our feet wet with a really important idea called the period of a function. I don't have the whole unit circle up here, but if you have yours in front of you, you see that these functions begin to repeat. So we have the unit circle here. And what we've seen is that when we go all the way around one time, we begin to get the exact same answers that we did before. So as we flip all the way around, we repeat ourselves. Well, the period means when do you start repeating? And what we're seeing is that cosine and sine repeat every time you get all the way around the circle. Secant is based on cosine. Cosecant is based on sine, so they must repeat in the same way. But now look what happens here. They're telling us that tangent and cotangent repeat sooner. Well, that's true too. If you notice on your unit circle, because of the nature of tangent being sine over cosine, we start seeing repeats halfway around. After we get through 1/2, notice that if you thought this through, the values of tangent on the bottom are the same as the values of tangent on the top. And so just because of what's happening with sine and cosine and the sines, the way like they keep canceling each other out, what happens is tangent repeats itself sooner. It only takes a half a trip around the unit circle to begin repeating. Tangent is obviously based on cotangent, or the other way around, cotangent is based on tangent, so both of those repeat halfway around, just with pi. Okay, now I was a little surprised by the next few questions in here. There's a couple that are good, but this is all repeat stuff, so I'm not quite sure why we're even doing this again. But I have a point on the unit circle. That's my cosine. That's my sine. And based on those two things, they want me to find all the trig functions. Well, we've been doing this for some time. I have the basic two. I'm just using the definitions to find the others. So I'm not going to work through this again. I've got that in the last two videos. Now this one though, this is a little more interesting because some interesting things are going to happen. So this is a quadrantal angle. I don't know how to say that very well. This is right on the y-axis. So I'm going to write down, here are my values. I've got the cosine. So remember the first one is 0. So that's, or is cosine. So cosine is 0. Sine is of t is -1. Okay, so I have this. Let's create all the others. Now an interesting thing is going to happen, so I'm going to go ahead and do this one. So secant is 1 over cosine, but look at what will happen. If I put 1 over 0, then I have undefined. So that can't be. So this one is undefined. So if I do cosecant, however, that's going to be okay. I have 1 over 1. So 1 over sine, that's going to be 1. That's all right. And then do you see we're going to have an issue again with tangent. Tangent is sine over cosine, so 1 over 0, well, that's going to be undefined as well. And then lastly, cotangent, however, is cosine over sine, so that's 0 over 1. That's okay. You can do that. That just makes 0. So we've done all this before, but here's some interesting cases that are worth taking a look at. Okay. Once again, this is a complete repeat here of what we've already been doing. I don't know why this is here again. So we have the values of sine and cosine. Well, we have our two key ideas. This is all we need to find all the remaining ones. We're just using the definitions again, plugging them in, doing any algebra that's required, arithmetic even, keep, change, flip, whatever you need to do, rationalize, and you get that. Okay, let me just check. Okay, well, there's one more thing. So I have my two basic functions here, so I'm good to go. I'm going to start with just tangent. So that's sine over cosine. So that's the same thing over the same thing. That's going to be 1. Well, if cotangent is that upside down, it's going to still be 1. Okay, well, secant is cosine upside down. So this is just going to flip it. I'm going to have 2 over the square root of 2. Rationalize that. Do some reducing. I'm going to get that. Cosecant. It's the same tune. It's 1 over sine, but the numbers are the same thing, so it's still going to give me radical 2. All right, now the last thing here is they're just telling us how we would do the cosecant, secant, and tangent. How would you do these on a calculator? Now, if you have a fancy one, I'm sure there's some place in there where you can, but the typical calculator, at least on the original keypads, like if you got an 83 or an 84, it just shows sine, cosine, and tangent. So what they're telling us here is, okay, you want to do those and you don't have a button for it. You could just, let me show you. So make sure you'd be in radians, for instance, in this one. You got to make sure in your mode which one you're in. But so what they've done here is they've done 1 divided by 5 times pi over 7. So they're just showing you how you would type that in, because that's cosecant. And then you take the sine. Yeah, I have to think about the order of that. And that's true. That would be the same thing as putting in cosecant. Although I think an easier way to do it would be just, if you just took the sine, like just did this, you could then do answer and then hit the reciprocal button, which is the x to the -1 key. You could do the same thing. Do you see what I'm saying? So if you just found the sine, well, we know cosecant is the reciprocal. Just hit the x inverse button, and that would inverse it for you. So you could do it either way. Okay, so what I would do here is I would do the tangent of -pi/8 on my calculator. I'd make sure that this is, and it's got to be in radians here. So I'd crunch this, and then I would use x inverse, and that's going to give me the value of tangent. Let me just, I don't want to do it because I feel lazy, but I'm going to just, I'll go ahead. Yeah, you know, I didn't think that was quite right. Yeah, you do type in tangent first, so it's not, hold on, let me check my mode. I forgot to see if I'm in radians. Yeah. Okay, so I'm in radians, so I'm doing tangent, negative, the pi button on mine anyway is above the up arrow, up caret, and then divided by 8. Okay, so I got -0.414. That's the tangent, but we want cotangent, so I'm going to hit the inverse button, which is on the left for mine. Inverse is going to flip that upside down, and I got a value of 2.414, -2.144. So again, the key there is just make sure that you're in the proper mode. Make sure you're in radians. Okay, hope that makes sense.